Okay, so we're going into 7.1, modeling situations with differential equations. So this is going to go back to a little bit of some Algebra 1 stuff. So we're talking about things that are kind of directly proportional, or we're talking about things that are inversely proportional. And we're using these rates that we've talked about. So for the first one here, the area of a circle is proportional to the square of its radius. Okay, the area of a circle. So if we have the area of a circle, we could say that that would be A is, so when we're writing equations, is always an equals, proportional to the square of its radius. So they are proportional. If it just says proportional, it doesn't say inversely proportional, then we're talking about this direct proportionality here. Now, anytime that we're doing these proportions here, we have to have this variable here, and we're going to call that our constant of proportionality. Now, when we're doing these, the variables are arbitrary, and we wrote that here. Variables can be arbitrary. That means that it doesn't matter what variable we're using. We could use, generally we're going to use k, but you could realistically use whatever you wanted. So we have this area of a circle, and it is proportional to the square of its radius. So if I take radius and I square that, I'm going to get r squared. Now, the only thing that we need to think about on these is, since they're proportional, they're going to have this constant of proportionality in them. So when we write this, we're going to actually say A equals K times R squared. All right, so the next one, the rate of change of A with respect to T is proportional to R. Okay, so the rate of change of A with respect to T. So rate of change, we're talking about a rate, and that is going to imply that we're using, dx dt, dr dt, d whatever. So we're taking, derivatives, go with rate. So the rate of change of A is going to be dA dt, because it's with respect to t, and that is proportional to r. So we're going to say k times r. All right, next one. The rate of change of y with respect to x is proportional to y. So rate of change, so that means we're going to do dy dx. You need to pay attention to what it is with respect to. So dy dx is proportional to y. So k times y. Okay, this next one gets a little bit more challenging, a lot more words. In a community of F farmers, the number X of farmers who own a certain combine changes with respect to time T at a rate that is jointly proportional. So we're saying like these two things are jointly proportional, which means it's mostly going to imply multiplication, to the number of farmers who own the combine and to the number of farmers who do not own the combine. Okay, so lots of words there. So first we need to figure out, we see this word is, so we know that's kind of separating our two pieces here. The number X of farmers who own a certain combine changes with respect to time t at a rate. Okay, so when we're talking about a rate there, we're going to make this a rate. So dx dt is jointly proportional to the number of farmers. So it's just proportional, so we know we're going to have a k here. So we're proportional to the number of farmers who own the combine. So if we're thinking about the number of farmers who own the combine, so here, the number X of farmers who own a certain combine, so that's X, and to the number of farmers who do not own the combine. Okay, so that's not something they told us, but we can figure that out. So we know that there is a community of F farmers, so a total of F farmers. We know that X of them own the combine. So if we take our total number and subtract X, we're going to get the number who do not own the combine. So this is our equation right there. Okay, and then number 5. For the first 9 months of life, the average weight W in pounds of a certain breed of dog increases at a rate that is inversely proportional to time t in months. So we have inversely proportional. So that's going to be this situation here. So instead of multiplying k and x, we're going to be dividing here. So one thing you want to pay attention to, so it says the average weight W in pounds of a certain breed of dog increases at a rate that is inversely proportional. So they didn't really give us two things for that rate, but if we really kind of look at it and think, it said for the first 9 months. So they're implying that we're talking about time. So that weight is changing over time. So we're going to say dw dt equals, so we have our is situation here, inversely proportional to time t in months. So it's going to be now k over t. Now the only thing extra that you have to look at on this one is this situation where t is on the bottom. And so since t is on the bottom, we don't want t to be 0. We don't want time to be 0 here. And also, it's talking about for the first 9 months of life. That's all it's talking about. So we need to have an area here, not an area, a domain that we set. So we don't want to go below 0. We don't want to equal 0. And we can go up to 9 and we can equal 9. So we can write it this way, 0 less than t less than or equal to 9. Or we can write it in interval notation. Remember, parentheses are saying that that point is not included. Closed brackets are implying that that point is included. So either one of these is really saying the same thing. So now I want you to pause the video. I want you to complete these questions on your own, and then we will come back and I will show you the answers. Okay, so if we're looking at these, so the rate of change of g with respect to t is proportional to the square of g. So this should end up being dg dt equals k g squared. 7, the rate of change with h, that might have supposed to say of h, with respect to t is proportional to the square root of h. So we have dh dt equals k square root of h. The rate of change of j with respect to t is inversely proportional to the square of j. So we have dj dt equals k over j squared. Number 9, the rate of change of m with respect to t is inversely proportional to the cube root of m. So we have dm dt equals k over the cube root of m. Make sure that you're not getting complacent and thinking that it's always going to be with respect to t, because that is not the case. 10. The rate of change of a population of bees B over time is proportional to the population of bees. So we have dm dt, sorry, db dt, looking at the wrong problem, equals kb. All right, this is where it gets a little crazier. Suppose a virus is spreading in a network of computers. There are m computers in the network. The rate of change in the number of infected computers is jointly proportional to the number of computers already infected, j, and the number of computers not yet infected. Okay, so a lot of information there. So there are m computers in the network. So first thing I want to figure out is what this rate is going to be. So the rate of change in the number of infected computers, okay, the rate of change in the number of infected computers. So we need to know what the number of infected computers is. So down here it said is jointly proportional to the number of computers already infected, j. So dj dt is, and it's jointly proportional. So we know we're going to have two things here. And it is jointly proportional to the number of computers already infected, j. So we have our constant of proportionality, we have our j, and the number of computers not yet infected. So we need to figure out the number of computers that aren't infected. So there are m total computers. If I subtract the number of infected computers, we'll get the number that are not. The rate of change of a level of response R with respect to the level of a stimulus S is a joint proportionality between the level of the response and the inverse of the level of the stimulus. This differential equation is known as the Brentano-Stevens law. Okay, so we have a joint proportionality here. If we want to figure out what the rate of change of the level of response R, so dr, with respect to the level of a stimulus S, ds, is a joint proportionality between the level of response, and if we remember, level of response is R, and the inverse of the level of the stimulus, so that was S. Okay, so we're talking inverse now, so we know there's going to be this fraction. So we have this joint proportionality, so we're going to have K R over S. And the last one, the height h in feet of a certain tree increases at a rate that is inversely proportional 2 times t in years. So we have dh dt, and it's inversely proportional. We're going to have that inverse fraction, k over something, so we're going to have k over t in this case.